Okay, I'm going to finish up with two more examples in this video. Feel free to follow along, or these would be really good ones to try on your own. If you're feeling super confident, go ahead and try your My Math Lab assignment. Reason I'm throwing this one in there, example 5, you do have a product rule right off the bat, and we haven't practiced one of those with implicit differentiation, although we did that the other day. So if you need a quick review of that, let's go ahead and work through this one. So I'm taking the derivative of both sides. Whoops. Both sides means that I'm going to go there, and I'm also going to do derivative of the right side. So I'm going to end up with, on the right side, 0. Sometimes I just like to get that out of the way. Let's go ahead and do the product rule. So I've got x cubed, my first, times my derivative of the second, which is derivative with respect to x of y cubed. Haven't actually taken the derivative yet. I'm just writing out my product rule. Plus my second function y cubed times my derivative with respect to x of my first function. And then I've got minus 4, which of course derivative of a constant is 0. So I've got plus 0, don't even need to really worry about that. So next line, let's go ahead and rewrite. I've got my x cubed and I've got my y cubed. But now I've got to deal with my derivatives. So derivative of y cubed with respect to x is going to be 3y squared, but I've got to follow that, since I am differentiating implicitly, I've got to follow that times dy dx. No surprise, we've been doing that all day. And then the next one, I've got derivative with respect to x of x cubed, and here's my normal one, so to speak, of use my power rule, 3x squared, and I don't have to follow it by anything. So finish that off, equal to 0, and now let's just kind of tidy things up and see what we've got. So I've got 3x cubed y squared times dy dx. I'm going to leave that in yellow just so I recognize what am I solving for. And then plus 3x squared y cubed equal to 0. Maybe you didn't need to do that step. I just needed to organize things a little bit. And now I'm going to solve for dy dx. So I'm going to get 3x cubed y squared dy dx. Just pretend that's a y, equal to negative 3x squared y cubed, because I subtracted that term right here, subtracted it to the other side, and now I'm going to divide by my 3x cubed y squared. So if you want to see that, y squared divide by 3x cubed y squared. And that's leaving me with, apparently it doesn't want to get rid of my original problem. That is leaving me with, try to write it legibly this time, dy dx is equal to negative, and I'm actually going to simplify things a lot here. Remember, easier to simplify now than later. We've got 3's cancel, x squared on the top and x cubed on the bottom, y cubed and y squared. So it looks like I'm ending up with negative, when it's all said and done, negative y over x. Pretty simple derivative for what we started with. I am pleasantly surprised and totally okay with that. So now I need to do my second derivative. So I'm moving that up and out of the way so I can refer back to it later, because I don't know what just happened there. I know I'm going to need to, and now I'm going to note that I am going to take the derivative with respect to x of my derivative dy dx, and that's equal to negative y over x, and I'm going to take the derivative with respect to x of that side as well. So let's do it. Derivative on the left-hand side, I'm going to get second derivative. And on the right-hand side, I'm going to have to do my quotient rule. So go ahead and do your quotient rule. That's going to be denominator times derivative of the numerator minus numerator times derivative of the denominator all over denominator squared. So I've got some tidying up to do, and let's see what we end up with. x times derivative of negative y is going to be negative 1 times dy dx. That's me doing this right here. And then I'm going to have minus a negative y is plus y times, let's do the derivative of x with respect to x, and that's just my good old 1. I don't have to follow by anything. All over x squared. And it's now time to make my substitution. Of course, I can tidy things up a little bit in the process. And just ignore this craziness that I have going on. I've got negative 1 times x times dy dx, and here's where I'm going to substitute in for this. I know that dy dx is equal to negative y over x. Whoops, negative y over x. And then I've got plus 1y all over x squared. So I really have one fraction here, and at this point I'm looking to do some algebraic simplification. Negative x times negative y is really a positive xy over x, but the x's are going to cancel. Negative times a negative is a positive, so I end up with a positive y plus another y gives me 2y over x squared. And that's my second derivative. I'm done. Keep watching if you want to see one more example. Next example would be another one where we're going to have to get we're going to end up with two terms that have dy dx when we do our first derivative, and we are going to have to do a little bit of factoring. So if you need to see another example, by all means join me. Okay, new page, and let's see what happens here. I don't know if I just lost my other video, but we'll just go with it. I think we're on example 6 now. So we've got y squared plus 2y equals 2x plus 1. And let's go ahead and find the second derivative. So derivative of the left, derivative of the right. If I take the derivative of the left-hand side, I'm going to end up with 2y times dy dx plus 2 is my derivative of 2y, but with respect to x, I'm going to have to multiply it times dy dx equals, on the right-hand side, derivative of 2x plus 1 is just a good old 2. And now that you've gotten here, recall that you're going to need to factor. We did this in one other problem today, but you should have done it quite a bit on your homework, I believe. 2y plus 2 equal to 2, and divide by that entire quantity to get to dy dx is equal to 2 over 2y plus 2, and please take my advice. If you can simplify your first derivative, please, please, please do so. So we should be seeing that we can simplify this. We could factor out a 2 in the denominator and say that this is really a 2 times the quantity y plus 1, and the 2's can cancel. So I know I just sort of made a mess of that, but let's scooch things up a bit. Dy dx is equal to 1 over y plus 1. That's going to be a much nicer derivative for us to remember. So let's get that out of there, keep that in the corner so we can use it, and continue on. So taking my second derivative, I'm going to kind of cut to the chase here. Second derivative, let's try to make it legible. And I've got two options here. I can make it a quotient rule, or I can do y plus 1 to the power of negative 1. I think we had that option one other time. I'm going to go ahead and use the quotient rule because I think most of you are going to be thinking that right now. So I could be wrong, but I'm going to go ahead and do the quotient rule. It doesn't end up too bad. So I've got denominator times my derivative of my numerator. I'll go ahead and write it out. Times derivative of 1 minus my numerator times derivative of my denominator. And if you don't know the quotient rule after today, something is wrong with you. And that's all over y plus 1 quantity squared. So let's go ahead and take my derivative would be my next step. I've got y plus 1 times derivative of 1 is 0 minus 1 times derivative of y plus 1. Well, derivative of y is really just 1 times, I'm going to have to multiply that times dy dx. Don't forget about your denominator, y plus 1 quantity squared. Now if we take a look at what we ended up with, y plus 1 times 0, that is disappearing. And now I've got minus 1 times dy dx. So I really just have a negative dy dx over y plus 1 quantity squared. Let's just kind of move this up here. I don't think we really need this part. So dy dx is equal to, we said we had a negative 1 times dy dx. Dy dx, of course, is my 1 over y plus 1. So I suppose we really don't need this that one. We have negative dy dx all over y plus 1 quantity squared. And I think at this point I'm ready to simplify my complex fraction because I only have one fraction in the numerator. I don't have to combine. So times 1 over y plus 1 quantity squared times 1 over y plus 1 quantity squared. So denominator is gone. Numerator simplifies to negative 1 over y plus 1 quantity cubed in the denominator. That, of course, is my second derivative. Hopefully you're starting to see a little bit of repetition here, and you're starting to see that these are doable and actually pretty easy. You do have a My Math Lab assignment, so go ahead and start on that if you still have some class time left, and or that's going to be your homework.